Hello. Today we're going to be talking about inverse functions. In chapter 2, we actually learned about what is a relation, and a relation is a mapping of input onto output values. And an inverse relation is actually, it maps out the output values back to their original input values. So an easier way to say that is basically the domain and the range of a relationship has been switched. For example, in this example here, let's say this is the original relation, so we can see the x's in this case are the domains, and we can see that the y's are the ranges. And an inverse relationship then would be the range becomes the domain, and the domain becomes the range of that relation. For example, in this case, all the x values are going to come from the y. So 4, 2, 0, -2, 4 will be all our x values. And then in this case, the y values would be -2, -1, 0, 1, and 2. So basically the x and the y's switch their places. The graph of an inverse relation is the reflection of the graph of the original. This is a reflection over the line y equals x. Or you can think about it as y equals 1x, where the slope is 1 and the y-intercept is 0. Alright, let's go ahead and look at an example. Let's go ahead and plot the point -2, 4, -2 and up 4, -1, 2, 0, 0, 1, 2, -2, I'm sorry, 2, -4. Okay, and what we want to do is graph the inverse of this relation. So that means, and I'm just going to go ahead and write these numbers so you can visually see it. This was a point at -2, 4, -1, 2, 0, 0, 1, it's a positive 1. Oh, I can't erase it. There we go. 1, -2, and 2, -4. That means that the inverse relation is going to have the point 4, -2. Notice that I'm just taking this point right there and switching the x and the y. And do the same for all the rest. So 2, -1, 0, 0, which doesn't change it. -2, 1, and -4, 2. Once again, we have taken all these points that you see right here and switched the x and the y's. Okay, so now once we plot those, we have plotted the inverse of that relation. So let's go ahead and plot those points. We have 4, -2, 2, -1, 0, 0, -2, 1, and -4. Did I go over 2? Yep, and 2. And basically, if we were to put those in the same spot, which I'm going to do that really quickly, what you'll notice is the points that we ended up getting are a reflection over the y equals x line. Okay, so I'm going to go ahead and just kind of draw the y equals x line. It starts at 0, it has a slope of 1, up 1 over 1, up 1 over 1, and it also goes the other way. So if I were to draw this line, you'll see that everything that's happening on the right side of the y equals x line is actually also happening on the left side of the y equals x line. Hence, it's a perfect reflection. Alright, let's continue. So how do you find the inverse relation given an equation? So for example, in this case, it says find the inverse of this. Well, the first thing we do, there's only really 2 steps. The first thing is we switch the input and the output, so the x and the y. So therefore, the first step would be x equals -3y plus 6. Notice that the only thing we switched is the x and the y. Instead of writing y, I wrote x, and instead of writing x, I wrote y. And then the second step is solve for y. Since the the equation here is in y form, we want to see it again into y form. So what we would do is solve for y. So we're going to subtract 6 on both sides. We end up getting x minus 6 equals negative 3y divided by negative 3. And we end up getting y equals, now this is 1x, so we can actually write that as 1 over negative 3x. And then negative 6 divided by negative 3 is positive 2. Or you can even write it like this: y equals negative 1/3 x plus 2. So either one of those is good. Alright, and if the two functions are, these are called inverse functions. Okay, so in this case we have y equals negative 3x plus 6 and y equals negative 1/3 x plus 2 as inverse functions, where they're inverses of each other. Alright, let's keep going. We're going to go ahead and try that one more time. Now, don't let this f of x equals x to the fifth scare you. It says find the inverse of the function. We know that f of x is the same thing as y equals x to the fifth. So nothing has really changed. We're going to go ahead and start with step 1, which is switch x and y. So that means that the original equation now will be x equals y to the fifth. And then the second step is solve for y. So we're going to get y by itself, which is what we have been working all throughout this chapter, is trying to get y by itself. So how do you get that fifth root, fifth power away? And I kind of gave that away. We're going to take the fifth root on both sides. And we end up with, those cancel out, fifth power and the fifth root. And we are left with y equals fifth root of x. So I'm going to just go ahead and write that. So it's y equals fifth root of x, where the y is on the left side. Not that it's wrong the other way, but I just like to see the y equals first. Alright, so we figured out the inverse of that function. Let's keep going. Now, an inverse function has a definition. So in order to prove that two functions are inverses of each other, we do have to use the definition that we see right here. And according to the definition, what it says is function of f and g are inverses of each other if this part is true, which means that f of g of x equals x and g of f of x equals x. That means both of those have to equal x. Notice that they're not saying equal to 0, equal to 1, equal to negative 3, equal to the same number. They're saying it must be equal to the value of x. The function g denoted by the inverse, so this is inverse of f, read as f inverse. So please don't read f of negative 1. It's going to be f inverse. Alright, let's try it out. It says we're going to verify if f of x equal to negative 3x plus 6 and g of x equal to negative 1/3 x plus 2 are inverses. Hopefully you recall that this was a problem that we just solved right here. So we do know that they're inverses, but our goal is to verify, and we're going to do that using the definition. So there has to be two parts to this. The first part is f of g of x has to equal x. Okay, so what that means is we're going to go ahead and take the g function and put it inside of the f function. So here's what that looks like. F of g of x equals, we're going to go ahead and take the f function, negative 3, a big blank, plus 6, and inside of that we're going to go ahead and put the g function, which is what we see right here, negative 1/3 x plus 2. So we're replacing that with x. Alright, we're going to go ahead and simplify, distribute the negative 3. We get negative 3 times negative 1/3 is positive 1x. That negative 3 times 2 is negative 6 plus 6. Negative and a positive 6 gives us 0, so we're left with 1x, which is the same thing as x. So we are good so far that f of g of x equals x. Okay, now we do need to still clarify the second part, because remember it said and. The second part needs to be true, which means that g of f of x has to equal x. So that's the next thing we're going to go ahead and prove. So I'm going to go ahead and write g of f of x, and in this case the f function will go inside the g. So I'm going to go ahead and rewrite the g function because that's the first thing I see. So negative 1/3. And instead of writing x, I'm going to put big parentheses, plus 2. And inside of those parentheses will be our f function. So negative 3x plus 6. We're going to go ahead and simplify that. Distribute the negative 1/3. And we are left with 1x minus 2 plus 2. The negative and the positive 2 just go down to 1x, which is the same thing as x. So therefore, g of f of x also equals x. And thus we can say that f and g functions are inverses, or are inverse functions. Voila! Alright. Let's do this one more time just so that you are good. The first part of this problem says, find the inverse of y equals 1/3 x minus 1. So remember, that's 2 steps. The first step is switch x and y. And then the second step is solve for y. Alright, so let's go ahead and give it a try again. Now here it doesn't say f of x, so we already have the equation, which is nice. Ooh, that's not negative. 1/3 x minus 1. So the first step is switch. There it is. We switched. Notice nothing else moved except for the x and the y. Those are the only things that switch. And then the last step is go ahead and solve. So we're going to add 1. We get x plus 1 equals 1/3 y. And in order to get rid of that fraction of a third, we're going to multiply by reciprocal, which is 3 over 1. Or you can think about it as just 3. Notice that I did put the 3x plus 1 in parentheses because the whole thing has to be multiplied by 3. And we are left with y equals 3x plus 3. I'm just going to go ahead and distribute that. So there's our inverse function. So that's the inverse of our function. Alright. Now it says that verify that y equals 1/3 x minus 1 and your answer for part A, which is this right here, are inverses. And this is actually a really nice way of checking your work to see if you did find the inverse. So I'm going to go ahead and write down our 2 functions. I'm going to go ahead and say that the first one, this one, f of x, is 1/3 x minus 1. And the inverse that we found, I'm going to go ahead and label that as g of x equals 3x plus 3. Notice that f of x, g of x, h of x, z of x, all of those just are representative of y. Alright, so the first step is we need to prove that f of g of x equals x. So I'm going to go ahead and start with the f function first. F of g of x equals, and I'm going to write the f function. Oh, I don't like that equal sign. There we go. And instead of that x, I'm going to put open parentheses minus 1. If there was 3 x's, I would have 3 parentheses instead of writing those x's. And then we're going to go ahead and input our g function in there, 3x plus 3. So you're putting the g inside of the f. And then you're going to go ahead and distribute, and let's see, we get 1x plus 1 minus 1, and you can see that equals x. Awesome. So the first part is done, but remember it's and. We need to prove the second part, which is g of f of x has to equal x. So I'm going to go ahead and write g of f of x and start with the g function, because that's the first one I see. So 3, instead of writing x, open parentheses, plus 3. And inside those parentheses will come 1/3 x minus 1. 1/3 x minus 1. Let's simplify that. Distribute. We get x minus 3 plus 3, which equals x. Therefore, we can say that f of x and g of x are inverses. And we actually verify that using the definition. Great job today. We will see you tomorrow. Continue to study your notes and make sure that you understand everything that we have done. If you have questions, please write them on the side so that we can answer them tomorrow in class. See you later.